Okay, so let's start. So welcome to this month's TSC meeting for EdgeLake as part of the LFH. You probably got the note and the invitation. So this month we are very lucky. We have Daniel Radza on the video. We should have probably Nicola if he can join. Nicola and Daniel are part of WINNIIO and they have deployed EdgeLake into smart building solution, which is very interesting. So Daniel has already helped us build a use case, but now he's going to present you the solution and feel free to ask all the questions you want. The plan is no more than half an hour presentation from Daniel, and then we can have an open discussion with questions. And Daniel, thank you again. So you can start sharing your deck, and I will go in mute mode. Thank you, Daniel.
All right, thank you. Let me know once you can see my screen. All right, thank you. Thank you very much, everyone, for joining. I am Daniel. I've been with WINNIIO for more than 2.5 years now, or almost closer to 3 now. And we have been working on a self-learning smart heating digital twin system that runs on the edge, and it works with edge native strategy. And today we are here, we'll present what the solution and also how EdgeLake or Anylog has helped us achieve that. And mainly I know EdgeLake and Anylog has differences, but I tend to use them like analogously. Yeah. So pardon me if I say Anylog or EdgeLake. We are currently using EdgeLake for our use case, but we have found, and we are in discussion with Eric and Moshe, where we have seen that there could be a lot more added value when we go to Anylog. So yep, let's start. Then the first thing that I would like to discuss is the objective of our project or product. So the idea is we have a lot of different buildings, and especially older buildings that are in the vicinity in all the world, right? And the problem that they go through are the systems that are inbuilt there. Mainly, what we are focused on is the heating system, so the HVAC system. And usually, how it operates, or how I have seen it operate, is you have these building managers or house managers that go from room to room or from radiator to radiator, and they set the uh, valve status there, or the pressure of the water or the flow of the water that goes through the valves. And that is what basically then defines the heating in the room, which is not really optimized. And of course, considering if we have a really large building, then a lot of energy goes into heating the water. And if that is not distributed properly, a lot of this energy is being lost. So what we have focused on is how we can reduce this carbon footprint and how we can optimize this whole process using AI. And in regards to that, or in complement to that, we also want to bridge the gap between humans, so what we as people know about the buildings and the building themselves. Yeah. So think of it from the perspective of, let's say, if building were a living breathing thing, how would you communicate with it? The problem today is building managers or house managers don't really, not always are aware of the complete BIM models, or the architect, how the HVAC system was laid out, and all of these different things. They don't always have the diagrams at hand to see how or what could be the problem. And what we are trying to solve is also through digital twins, bridge that gap where you can quickly and in a faster way see what's going on, what the problems are, or where the problem could be, and then make informed decisions. So the value that we add is the decision making, and how quickly and effectively we can make those decisions. At the same time, we leverage the power of AI to help the building do a lot of these things by itself rather than needing human supervision. So In terms of the solution, we are working towards what we call reality gamification. As I said, the digital twin aspect, we have converted that into not just simple graphs or some 3D models per se. We have built it into an interactive game where you can roam around into the building. I'll also show you a small walkthrough. Um, Not live, but I'll show you a video of the walkthrough. And you can see that you can roam around in the building. You can go from room to room. You can see the complete HVAC system, how it was built under the hood. And at the same time, see the status of the building. So what's going on in the building, especially related to the temperature, the humidity, the CO2 sensors that we have in built there. What we are working towards with this is going from BIM to a digital twin, and at the same time getting real-time data in. So that real-time data comes from the IoT sensors that we have in place. And then when you see it in a 3D model in a visual way, it's much more easier for us as humans to understand and also take it forward and find solutions and make really effective strategies. The next part of our solution is the AI side of things, and the data flowing from all the way from sensors to the 3D model or to the game is one aspect of it. And we here at EdgeLake, what EdgeLake has helped us achieve, or Anylog has helped us achieve, is exactly optimizing that pipeline of data ingestion to data visualization all the way through and everything in between. What the other aspect that we have been working on is, once we have that data, how do we leverage AI into this? And as I already said, that the buildings are really old, and then we have manual inspection over it. And those manual inspections or manual walls that we at home usually do, like you set it to 3, 4, 5, whatever you have the valve at, or if you have a digital one, you can set it digitally. But then at the end of the day, there are times when you don't want it running when you are not there, right? And you have forgotten to turn it off or something, or it's just wasted energy at that point. For us, it might be also wasted cost, because you have to pay the bill at the end of the month or at the end of the year. But that is also one of the concerns of really public buildings or larger buildings, where you cannot have people going in or out at that frequency, or you cannot have a person looking after all of those rooms. That's also expensive. So where does AI comes in? What does AI do is it tries to predict the temperature for the next hour, for the next 2 hours, and then based on the prediction, it tries to take preventive actions in order to not reach that level. So for example, if we have set the temperature of the room to be at, let's say, 21.5 degrees, right? And then provided the air that we want it to be 21.5, right? So based on the sensors, it will collect the data, it will start predicting temperature, and it will get to a level where it will try to keep that temperature closer to 21.5. And the way to do that is, if the prediction says it will get to 23 degrees, and it's a slow moving system. So if the prediction says it will get to 23 degrees in the next 2 hours, we will take action now to not get there and to stick with 21.5. So what we can see here in the graphs is this, the top graph is the predicted versus actual temperature in the building. So we can see that the overlap between actual and predicted temperature is also a lot, which means our predictions are really good. We can predict to a precise level of 0.05 degrees centigrade of error. And the lower graph, it shows that before the actuators, before AI, if we were running a simple rule-based system where it would be like, okay, if it will get to 23, reduce it a bit, reduce the the radiator, like close the radiator a bit, and if it's going below 21.5, then turn on the radiator a little bit at a time. And if we were running a simple rule-based system, we could see these lines indicate the water flow through the radiator. So the larger the curves, that means the more water is flowing through it, the more fluctuations are happening. And when we introduce AI, within a matter of a week or two, AI could then start regulating and it's not fluctuating that much, which means the system is stabilizing. It has found that sweet spot of the radiator where the temperature stays constant, and it knows when to make those changes in order for that to be constant throughout the day. So the next thing is the walkthrough. This would be interesting. Let's see if this plays. Yeah, and I'll do a commentary. So this is the 3D model of the building that we have where the system is live. It's a school in Sweden, and you can see, I could see the inside the rooms. I could remove the roof. We can turn on the lights. So all of the 3D aspects of it. And you can see those red and blue colors. Those are the radiators where it's showing where the cold water is flowing in and when the hot water is going out. Oh, hot water is going in and cold water is flowing out. And then you can see the status of all of the rooms. So green means it's at the ideal temperature that we want. Blue is cold and red is that the room is warm. So you can see in a bird's eye view which rooms are cold, which rooms are good. And I'll just stop here, and you can see here that this side of the building, all of these three rooms are cold. And this could be not that all of the radiators stopped working at the same time, but this could be a reason that there might be a blockage or a flow problem with the HVAC system. Why are these rooms not getting enough hot water, or the temperature of the water while it gets there isn't that much to impact the temperature in the room? So these kind of problems could only be identified if you have such a system, such a visual system that gives you a bird's eye view or a hawk view for the complete system in like one screen or one small screen. And with the gamification aspect of it, you can actually go and you can turn these things. Like here we can see actuation is at 100%. So actuation is what we call the radiators. So radiators are at 100%, meaning 100% open, but the room still is at 19.4 degrees. So that could be, uh, this area is something for the building manager to ponder upon and to look through the data, go into the details of the data. We do provide a lot of graphical and a dashboard analysis on of the data that is being collected, so they can go through it, they can actually see what's happening. And we are also working towards a simulated environment where you can then go back in time or go into the future and simulate what either what happened or what might happen. So you can run all those different scenarios and you can actually see where the system might be a problem or where it was a problem. And that is really useful in today's world where we have a lot of systems in place, a lot of systems like just in this building, we are working on the smart heating system, right? Just the heating system. There are a lot more systems in the building that are running simultaneously. So these kind of visualizations are really useful and helpful in order for us to be smart, effective, and make more and more informed decisions. Next, I would come to the important part, why we are here and how EdgeLake or Anylog helped us achieve some of the problems that we had in the architecture and resolve a lot more and made our architecture much more simpler. So here you can see the architecture that we have. So in each of the rooms that I showed you, we have 4 different sensors and 1 actuator. So the sensors we had were temperature and humidity, CO2, motion sensor, and a switch sensor. Motion sensor to detect if there are actually people in the room, and we could potentially figure out how many people there are. The more motion there is, that means a lot more people are in there, right? I mean, it's not very like, yeah, there could be an another where someone is running round and round in the room, and then we could take it as like, yeah, okay, there are a lot of people in there. But if someone is running around and around in the room, they would probably feel a lot more warm than they usually would when at rest. So we do have to turn the radiator off a little bit to make the room a little bit colder for them so that they don't feel that hot, right? Um, and then the switch sensor that we have, this is placed on the windows and the doors in rooms to to give us the indication if the window is open or if the door is open. And that will let us know like, okay, if even if the actuator or the radiator is at 100% open and the room isn't getting warm, maybe the window is open too, right? So we cannot, the heating system cannot do anything at all. We need some external help in order to close that window, because the windows are manual in the buildings that we are working with. If they are also automated, we can also potentially cover that ground with AI. The last is the radiator valve. So the radiator valve that we have are all digital. They can be controlled by digitally through a software, and we have made services to connect with those, and we can control them remotely. All of these sensors in four sensors and one actuator are in one room. And then we have the building that I showed you, we have roughly 49 rooms where we have all of these sensors placed. So these are all connected through a wireless mesh. And then we have a system and an edge gateway that is placed in the building where we run all our services. So WINNIIO, as a philosophy, we go with edge native strategy. We everything we do, we try to do edge native first, and that is our motto. With yeah, just a side comment here. You may have heard about cloud exits now, but we have been foreseeing this, or Nicholas has been foreseeing this for some time. So yeah, we have been working with edge native strategy or edge first strategies. So all our services, the AI, the data processing, data collection, everything can be done on the edge. For us, the cloud part is optional. And that makes our, that has its fair share of challenges, but we are determined to solving them. And EdgeLake or Anylog has helped us quite a bit in achieving that. So one of the other limitations or the challenges that we had was network consumption. So because all our data is residing on the edge device, and all the processing is being done there, but there are services where you need that data outside of the edge device. And in order for that to be outside on the edge device, if you are to query the edge device a lot, it puts a strain on the edge device, number one. So you have limited compute resources, limited memory on the edge. Second problem that we had is all of our edge devices come with 4G network, right? So we also want to minimize our cost on data transfer. And that was one of our challenges that we had to solve. Then I just showed you one of the buildings. We are running this on two more, and we do want to scale it to a lot more. Currently, or not currently, but previously with this architecture, we were having issues with scalability because we have this the nature of our business is distributed, and we do want all of that data to be available in the cloud if the customer opts for it, but then we don't want to set up separate clouds for each customer. So we needed some form of aggregation there, and the distributed nature or this architecture doesn't really help a lot with this. We did manage to achieve it, but it was a lot of maintenance required. The other challenge was data backup and security. So again, if you opt for a cloud, data backup is um, simpler, get simpler. But if you are just on the edge, how would you back up your data, right? That's a challenge in itself. Then we have one of the sorry one of the challenges, or one of our requirements, I wouldn't call it a challenge, one of our requirements is we have bi-directional communication. And with bi-directional communication, meaning that we have actuators that are to be controlled not just by AI, but you can do a manual override. And that manual override means we just don't want the data to be sent here, collected here, and then shown on these different interfaces. But we also wanted data to flow from these interfaces back to the sensors, or mainly back to the actuators, right? And this bidirectional communication poses a challenge on how you would, if it's only on the edge, how would this mobile app work, right? It has to be through some common interface. I cannot have different mobile applications for different locations. So all of these challenges were there, and we did manage to solve a lot of these with our previous architecture, but that came with their own maintenance, their own cons, their own caveats. With Anylog, what we did is we simplified a lot more of the architecture. So just take focus on one site right now. I know there are a lot, but focus on one site right now. What changed was, instead of having a MySQL in the edge and a MySQL in the cloud, we had EdgeLake operator nodes, right? Or Anylog operator nodes that serve as databases for us. And then what we had is, in the cloud, we had the master node and the query node. And what really helped us is, now, irrespective of where this operator node is, I can replicate just this same architecture on multiple sites, and all of these are connected as if all the data resides in one database, which is the beauty of Anylog, and I think the greatest solution that we could hope for. Yeah. So once they are on the EdgeLake network, meaning I don't have to worry about like the connectivity of the different edge devices. Anylog and the EdgeLake network can solve it. They have already solved it, and they can take care of that connection. Of course, if the connection is down or something, they can help me um, identify what the problem is. We can find a solution, but I don't have to worry about managing that network. So that really helps us taking one thing off our plate, and we can focus on the thing that is most important for us, which is the digital twin, the 3D aspects of it, and the AI side of it. Secondly, as you can see in the last architecture, I only showed you one site, right? So this is just one site. We are not talking about multiple sites, because in order to go to multiple site, I had to replicate a lot of different things, and I have the setup and the management and the maintenance of it was difficult. But with EdgeLake, that is very simpler for me, because it's exactly the same thing, just replicating on a different site, on a different location, and I don't have to worry about anything else. I just have to make this operator node part of my network, and that's it. Everything else is taken care of, everything else works the same. So with Anylog and EdgeLake, we were able to scale our solution very rapidly. Then comes the network bandwidth part. So the network bandwidth part, one of the main reasons for the network bandwidth, or reducing one of the bottlenecks in the last architecture, was we had mobile application. We were forced to connect mobile application separately via REST interface, which would get data directly from the edge device. And then we also had Kafka Streamer, which would stream data to the cloud so that cloud can also back up, right? We yeah, I couldn't connect mobile application to the cloud directly because mobile application was one for one location. I had one mobile application, right? I didn't had a way to have one mobile application and then reach out to a lot of different edge devices separately. So we were connected mobile application via the REST interface. And this means that the same data that is coming in. So let's say if a temperature in room 2 sends a message that, okay, the temperature in room 2 is 24 degrees, it will get stored here. Mobile, if mobile application needs it, it will ask for it, and it will also be streamed. The same data packet will be streamed via Kafka to the cloud. So the data packet going out of the edge is not just through Kafka, not just one stream, but there are multiple streams. And if I'm sending the same packet again and again, which means I'm using the bandwidth here, right? So with EdgeLake, that is not the case, because once the operator node is receives the data, we are using backup strategies and replication strategies that replicates the data on the cloud. And then mobile app and all the other apps are connected through the master node here or the query node here in the cloud. And this query node, we have set it up in a way that it's smart enough to first search the cloud if the data is there. If not, then it goes to the respective edge. So it only goes to the respective edge if the data isn't replicated here. And data not being replicated here could be because of two reasons. One is just the latency, right? So you request it now and maybe the latest data isn't here because of latency. The other reason could be that this client of ours hasn't opted for the cloud. And if they haven't opted for the cloud, we cannot reduce network bandwidth a lot. You need the data, you have to fetch it where it's stored from. You cannot reduce the network bandwidth by not fetching data from there. So this is how easily we could replicate and we could resolve these issues. Lastly is the uniform access protocols. So what we have in the previous architecture, and I'm going back and forth just so I can be more and more clear. Um, we had the REST interface, we had the Kafka streamer, we had MQTT that is working between that is communicating data between microservices. So we had a lot of different protocols in use for different services from the cloud. We also had a GraphQL access. We also had a REST interface from the cloud. So we had a couple of different working with microservices architecture. It really is a challenge to make sure that you have some uniform protocols in place. But we had a lot different uh, protocols, and that sometimes is a problem when you come to maintain such a big platform. So with EdgeLake or Anylog, we are now focused on the interfaces provided by Anylog or EdgeLake. And EdgeLake provides a lot of those, right, already out of the box. So we don't really have to worry about building those different interfaces ourselves. We know all our data is here in the operator nodes, and we have the master or the query node. Doesn't matter how I access it via REST interface, via the Anylog browser or something, browser web app, or I access it via some other interface that Anylog provides. It's one and the same thing. I don't have to worry about those things. Anylog has taken that off my plate of creating new interfaces to interact with the same data. So we also have a lot of 3D, not 3D, sorry, third party vendors who need access to our data. So those can now connect. We can just provide them the interface for Anylog, and they can choose which interface they want to fetch data from us. And we don't have to worry about if someone says, yeah, I need a GraphQL, right? I don't have to worry about that. If Anylog supports it, they can very well use GraphQL. Anylog supports REST interface, they can use REST interface. So I don't have to worry about those things a lot in for my platform. So this is what we have. What other steps or what we are currently also working with? This is not, I mean, we have our architecture much simplified, but I said in the starting, we have only currently implemented EdgeLake. We are looking into Anylog, and with Anylog, we get the added benefit of publisher nodes. And Eric or Odi, correct me if yeah, if something that is also in EdgeLake and I say it's in Anylog, do correct me there. So uh, we get the added benefit of publisher nodes. With publisher nodes, we don't have to create our, as I understand, we don't have to create our own replication strategies. Publisher nodes can take care of those for us. And that takes one more thing off our plate. The next thing is, as I mentioned early on, that we need bi-directional communication. And in order to do that, we have our own service in between. So we send commands, we dump commands into operator nodes and in a table. And then we have a service that is constantly looking at that table. And as soon as a new command comes in, it picks up and then processes that command, send it to the device, whatever the command has to do, it just does it and then reports back the status. And all of this is currently built in, like, we have built it ourselves, so we have to self manage it. But I think a month ago, Eric and I were having a discussion around the architecture, and Eric told us that, yeah, we do also have rule sets that we can use to trigger commands. That's one more thing on our plate that we can implement via Anylog or EdgeLake. And with that, we would have taken care of not having a personalized or a specialized command processing service. We can just create rules and Anylog can trigger those commands for us. Uh, Secondly, we already have things in place where we are working with, as I said, there is limiting the data that is going out of the edge device. There is only so much I can do. But what I can also work on is, in order to reduce my network usage, I can reduce the packet size. And to reduce that packet size, we are working on implementing gRPC for our packets. EdgeLake and Anylog, both of them already support gRPC ingestion. So we have had discussions with them, and we are working towards implementing that in our system so that our packet size are also reduced more compressed, so that we can further reduce our network usage. And lastly, data purging and archiving. So once we have those publisher nodes, there is only limited amount of storage on the edge devices. We cannot keep everything on the edge. And if our client or our clients don't want the optional cloud, then of course there will come a point where we will have to purge the data that is on the edge. Maybe you can only keep a couple years worth of data depending on how much data is being collected, but there would be a need to have that process in place. And if they are opting for a cloud, then we don't necessarily have to burden the edge device to even have that much data. We can only keep 3 months or 6 months worth of data on the edge, and everything else is in the cloud. And I already shared with you that we have implemented strategies where the query node or the master node first looks through the cloud for that data, and if it's not that, then goes to the edge. So historical data would never have to be fetched from the edge, and it will never reside on the edge at all. So these are the next steps and that we are working towards, and hopefully in near future we will have much more simplified architecture, much more uniform protocols, and a much more robust and production ready system, although it's currently still in production, but much more robust and fail safe, and yeah, system that we can rely on, that can run even without the cloud. um, so yeah, that's it from my side. I'd like now to open up the floor for questions.
Thank you, Daniel. And just that's Eric, just one comment. So the only thing that's not in EdgeLake is the publisher node.
Yes, okay.
All the rest, the policies, the rule sets, this is all EdgeLake.
Hmm. Okay, that's good.
Uh, I have a comment. First, Daniel, thanks a lot for the presentation. Really great presentation. Thanks. Um, Wanted to share, not to. We used. Thank you for. So I'm in Denver in a open source conference, open source summit, and we used your use case and data that you shared with us to show federated learning, which got a
Hmm.
lot of attention. So in federated learning on top of your model, rather than aggregating the data to do the training,
Hmm.
each one of the nodes at the edge did the training independently, and there was an automated process that aggregated the models. It created huge attention. I mean, lots of companies reached out to me and said, that this is super interesting, and so it's probably something that we need to take offline, but a lot of interest there. So um, this is also something to think about, and I'm sure we would collaborate on that. It's really triggered a lot of interest. So I think there is
Yes.
something really unique here, and that we could show in terms of the AI part.
Yes, yes, definitely. So I think for this presentation, I didn't go into a lot of details about the AI, but we do have, as I said, we are working towards an edge first strategy with an edge first strategy. So all of our training is done on the edge even today. So we don't train our models in the cloud. We do have like a master model that is trained on a lot of data from a lot of different places, also open source data, which we use as the base, but the actual training happens in the edge device. And the challenge that we have right now is, of course, with the limited resources of the edge device, there are only so many models or so much training that I can do. I have limitations when I want to train, I have limitations on the algorithms I can use. And one of the reasons for us also working on federated learning, we have been working on it for a while now. And as you mentioned, that yeah, we also collaborated on it a little bit, and we should definitely collaborate on it in future. One of the reasons is we want to use a lot more advanced algorithms, and in order to use those advanced algorithms, we also don't want to train them or to get all of the data out into the cloud, train it, then push the models back, and go through all of that exercise uh, with someone else's data. We want them to be able to use the knowledge of the domain that a model has collected, and it has collected that anonymously. It should be able to collect that anonymously and just go with the crux of it. And I think this resonates a lot with how we as humans learn, right? So I don't have to, if I am going to a different room right now, I don't have to learn anything. Okay, should I turn the radiator on, off? How much should it be turned on? How much should it be turned off? I just know that okay, it's this big of a room. This is what I'm feeling the current temperature is. This is where it should be, right? And I can adjust it over time, and I can find the sweet spot that works for me. And I think every one of us in our homes, in our bedrooms, we know what setting works best for us, right? We know what to set the radiator to, what to set the Yeah. So thermostat 2, all of these things we already know. And that comes from the universal learning that we get through our environment. And we want to achieve that. And in order to do that, I do think that federated learning is the way to go, because it also solves the problem of not sharing your unique information or personal identifiable information with others, just sharing the knowledge, just sharing the information.
Thank you, Daniel. Thank you, Nicola, even if you couldn't really activate your connection. And so that concludes our monthly call, and we speak to you in a month. And if you're interested in WINNIIO, you can find them on the internet. Very easy.
Yes.
Thank you again, Daniel,
Yeah.
for being there today.
Thank you.
Thanks, Daniel.
For the invitation.
Thanks. Great
Thanks.
presentation. Yeah.
Bye.
Thank you.
so much.
Thank you. Bye.